Hi, welcome to Lesson 10, Structure of Ratio Tables. Additive and multiplicative properties will be used. Today's classwork starts with an exploratory challenge. Imagine that you are making a fruit salad. For every quart of blueberries you add, you would like to put in 3 quarts of strawberries. Create 3 ratio tables that show the amounts of blueberries and strawberries you would use if you needed to make fruit salad for greater numbers of people. Okay. So you'll need to make 3 tables. The first table should contain amounts where you have added fewer than 10 quarts of blueberries to the salad, which means you should start with the first one, the first ratio, and then continue on, but you can't go past 10. It has to be fewer than 10. The second table should contain amounts of blueberries between and including 10 and 50 quarts. The third table should contain amounts of blueberries greater than or equal to 100 quarts. And here is an example of what your chart should be. It shouldn't be more than 5 lines down and 2 sets, one for quarts of blueberries, one for quarts of strawberries. So go ahead and take some time to make 3 tables and follow the directions on how the tables should be made. For the first question, after we've made our tables, you'll need to describe any patterns that you see in the tables and be specific in your description. So spend some time really thinking about them. What do you notice? What patterns do you see in these 3 tables? Take some time to write about them now. Question B says, how are the amounts of blueberries and strawberries related to each other? What kind of patterns do you see in their relation when you go from blueberries to strawberries? Well, did you notice that the amount of strawberries is always 3 times the amount of blueberries? In addition, you could have noticed that the ratio of the number of quarts of blueberries to the number of quarts of strawberries is always equivalent to 1/3. Let me show you what So if your ratio looked like this, if your ratio table looked like this, you would have blueberries on one side, strawberries on the other. You would have 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12. And so if you notice, if you put each one of these in their value, this would be 1/3. This would be 2/6, which equals 1/3 when you simplify it. This would be 3/9, which also equals 1/3 when you simplify it. And 4/12, which also equals 1/3 when you simplify it. And so that's why we said that this is always equivalent to 1/3. All right, now let's look at C. C says, how are the values in the blueberry columns related to each other? So look at all 3 tables. Look at just the blueberry columns, and how can you say that they are related to each other? Well, when you look at the values of the blueberries, did you notice that there's addition repeating when you go from one to the other? Again, let me show you what I'm talking about. So if you look at one of your ratio tables, if it looks something like this, where you had the 10 and you went on down, you would notice that to get from 10 to the next one would be by adding 10, and then you add 10 more, and then you add 10 more. And though this is why we say that there is addition repeating throughout. Now, knowing that, how are the values in the strawberry column related to each other? If you look at the values in the strawberry column, what do you notice about them, and how are they related to each other? Look in your columns and your ratios tables and see what you see. See what you can figure out. Well, if you noted that in the strawberry column, much like the blueberry column, they're continually adding. So again, we have addition repeating throughout. Same thing in the strawberry column as in the blueberry column if you're going just straight down. All right. E asks, if we know we want to add 7 quarts of blueberries to the fruit salad in table 1, the first table you made, how can we use the table to help us determine how many strawberries to add? Well, we know we're going to put 7 quarts of blueberries. So how do we use a table to tell us how many strawberries we need to add? Don't just tell me how many strawberries to add. How do we use a table to help us do that? Now the key to this one was the question, what the question was asking us to find, because I bet many of you just wanted to tell me how many strawberries we would need to add. But that is not the question. The question said, how can we use a table to help us determine how many strawberries to add? And the way we use the table, is by extending it until we get to 7 in the blueberries column. All right, letter F. If we know we use 70 quarts of blueberries to make our salad, how can we use a ratio table to find out how many quarts of strawberries were used? Again, don't get caught up. Make sure you know what the question's asking you to find and answer the question. Well, we could start with a ratio 1 to 3 that was given in the description, and then multiply by 10 to get 10 and 30. Instead of 1, we can multiply both sides by 10 and get 10 and 30. These would be the first values in our table. Then we could count up by 10s in the blueberries column and count up by 30s in the strawberries column. Or you may have said that you can go ahead and use your ratio that you already have started. This was assuming that you didn't have a table ratio already given. You might have said that you can extend it or something to that effect. This is a general idea of what you could have said. I'll look at what you actually said. Okay, for exercise 1, you have a table here, and below it are other tables on your paper. But right now we're looking at just the first table, Table A. The following tables were made incorrectly. Find the mistakes that were made, create the correct ratio table, and then state the ratio that was used to make the correct ratio table. All right, so be very careful, and let's see how you do before I show you how to do it. All right, so the first thing you want to look at is, it looks like to go from ours, it was by adding 2. So this would have been plus 2, plus 2, plus 2. So that seemed okay. In this case, if we look next how we went from 3 to 24, well, let's go from there. 24 to 40 looks like it was 6. This one looks like, no, that's not quite the same. So that couldn't be a good way of figuring it out. Let's try from 3 to 24. How did you get from 3 to 24? Could you have multiplied by 8? Sure. We could multiply by 8. How about 5 to 40? Could you multiply by 8 again? Sure you can. So 5 times 8 is 40. That looks like a pretty good pattern. What is 7 times 8? 7 times 8 is not 52. We'll have to go and look at that. What's 7 times 8? Right, 7 times 8 is 56. So 56 kind of goes over here. What's 9 times 8? Yep, 9 times 8 is 72. So everything works except for this one. So your new one, ratio table, should have all the information the same except for this number being 56 instead of 52. Very good. And so that's what it looks like. Now, if we're going to look at what the ratio is, it would seem that it's just 3 over 24. We can write that in its value, 3 over 24. But here's my question. Is there a way to simplify this ratio now fraction? Sure, you can divide the numerator and the denominator by the number 3. If we divide them both by 3, we get its simplest form, which then equals 1/3. I'm sorry, 1/8. 1 over here. 24 divided by 3 is 8. You know that from doing it over here. 3 times 8 is 24. So that's 1/8. How about 5/40? Is that 1/8 as well? If you divide the top and the bottom by 5, you in fact get 1/8. So if you do all of them like that, you end up with 1/8. The ratio, if you turn it back into written this way, you could say is 1 to 8. You could also say it's 1 with the word to 8, or you can say it's 1/8. All of that would be correct answers. Okay, now you look at B, where blue and yellow. See where there's an error? Correct the error, fix up the new ratio table, and then come up with a ratio on your own. Okay, this one was a bit more tricky, but to get from 1 to 5, you multiply by 5. So this one you need to multiply by 5, so it's not 4 to 8, it's 4 to 20. 7 you multiply by 5, and you get 35, not 13. And when you multiply 10 by 5, you get 50, not 16. And so the only one that was correct in this one was the first one. The ratio in this case is 1 to 5. So here's our lesson summary. Ratio tables are constructed in a special way. Each pair of values in the table will be equivalent to the same ratio. So 3 to 12, 6 to 24, 21 to 84, they all have, when you write them and you simplify them, if you were to write them in fractions, you would have them all be 1 to 4, or 1/4. Repeated addition or multiplication can be used to create a ratio table. The values in the first column can be multiplied by a constant value to get the values in the second column. So here's the first column, here's our second column, here's our constant, the number that doesn't change. In this case it was 3 times 4, 6 times 4, 12 times 4, and 21 times 4. So that's one way that we can fill in our ratio table. And just by adding a certain number to the first entry of a ratio in the first column and adding the same number to the second entry in the second column, the new ratio formed is generally not equivalent to the original ratio. Instead, the numbers added to the entries must be related to the ratio used to make the table. However, if the entries in one column are multiplied by a certain number, multiplying the entries in the other column by the same number creates equivalent ratios. Okay, so for example, 3 to 12 is, and 6 to 24, 6 to 24 and 12 to 48 are not necessarily going to always be equivalent. However, if the entries in the one column are multiplied by a certain number, multiplies in the entries by the second column by the same number can create equivalent ratios. So if I multiply 3 times 7, I'll get my 21. If I multiply 12 times 7, I'll get my 48. So that's one way of looking at it. All right, and so now we have Lesson 10's exit ticket. Show more than one way you could use the structure of the table to find the unknown value. Showing the unknown value. So you have to show more than one way that you could use the structure of the table. You know a few different ways, particularly with additive and multiplicative properties. So use one way or another, and then show another way, at least, that you've figured out the answer for these two.